Welcome back to another episode of Revolt Garage. The last couple of videos we've been talking about battery management systems. So today we're going to talk about what the battery management system is managing.
Is it batteries?
It would be batteries. Now, not just batteries. There are different kinds of batteries, different configurations. But first of all, I was gone for a week.
Oh, dang. Certified technician.
Yeah.
We're legit, people. Look.
Yeah, we're legit.
We got a piece of paper that says so.
Yeah. So I went to the training in Arizona over at Legacy EV. And how this came about is one of the days, a complete day dedicated to batteries, battery management systems, battery configuration, all very important parts of building an EV. So, speaking of building EVs, the latest copy of EV Builder's Guide, compliments of Lando. All right, thanks. So Lando picked up a copy, and you notice dock is on the front page, and guaranteed fair amount of batteries inside the dock. All right. Next, what we have here, a couple different kinds of batteries. So Eddie B, why don't you tell me about this guy? What do we have here?
So this is a module out of a Tesla Model S, specifically a P100D model.
So the big one.
The big one. So when you see those numbers, P means performance. 100 is the size of the battery pack. It's 100 kilowatts. And D is dual motor. So they have a motor up front and a motor rear. Some of the new Teslas, Model S's, they're plaids, have 3 motors. Batteries are a little bit different than this, but this is off of the first generation of a P100D Model S pack. So that's what we're looking at here. That's almost 500 cells inside of it.
Okay, so now, got a couple questions for you on that note. I'm guessing one of these is not going to power a Tesla. So what would this look like? What kind of configuration would this look like inside a Tesla?
So basically in the floorboard of the car, there's 16 of these modules.
So you stack them up 16 high?
Nope.
That's pretty tall.
Wide. So it's all pancake. You want to get your center of gravity as low as possible. And it's really important when you guys are building EVs. We see a lot of conversions. Hey, and we got to do what we got to do, but people put all their batteries in the trunk or underneath the hood, which now you have space for. Unfortunately,
someone asked me if they could put them in a roof box. Keep them out of the space of the car, right?
Well, that would make a really high center of gravity.
the Teslas have about almost 1,000 pounds of battery inside of those vehicles. So that's a lot of weight to be carrying around. It's like putting, 4 or 5 big dudes on top of the roof of your car. Things can handle like a bag of you-know-what.
Okay, all right, so that's a Tesla pack. Now what do we have here as opposed to the Tesla pack?
So just to kind of go back on Tesla pack, they look like this. They're rounds. We call them round cells. These are 18650, so 18 millimeters in diameter and 65 millimeters long, so that's kind of an industry standard. And those sit inside here, and you can see all the tops of them. These are prismatic cells, and we also have an NMC cells, so basically these are not round, obviously, they're square, and the anodes and cathodes are actually stacked kind of like a sandwich. So these are made for large energy discharges. So if we want to dump a bunch of energy, these are the better pack. If you want longevity, this is a better pack. So we got a sprinter over here, we got a long distance runner. When we do racing, we tend to go on this side of things because these provide more energy to us in a faster rate. So that's called C rating, that's your discharge rate. Also, they could charge a little bit faster too, and we could dissipate more heat out of them because of more surface area on it.
So question, all right, comparatively, this is one battery, this is one battery?
Correct.
Okay, so how would you configure these differently for, let's say I want to drive the dock 200 miles, I want to race the Hillbilly Deluxe a quarter mile. So how are you going to configure these differently?
So we can't really do much with the Tesla modules because they're already prepackaged. This is a 6 in series. And what we do is we run 16 of these to get to the 400 volts. So we have to put 16 of these inside of the Hillbilly Deluxe to make it run right. Unfortunately, we don't like the voltage sags on them, so that's not something that's ideal for racing. But they'll get you 200-300 miles, get you LA and back. These, what we'll do is we'll stack them in parallel till we get the right amount of amperage that we need out of them. So I tested these cells. We ran about 400 amps through them, and they were getting a little bit warm. So we kind of cut that in half and said, okay, 200, 250 amps is what I could pull out of one of these little batteries. So what I'm going to do is I'm going to parallel them up until I get to about 2,500 or 3,000 amps.
So what's the big deal with the, I mean, it got a little warm. So what?
You don't
Why, what's wrong with getting this a little warm?
Well, batteries of this nature don't like being warm. They're like us. They like 75 degrees and sunny. They don't like to get cold either. If you get these things too warm, what will happen is they'll go into a thermal runaway, which causes fires. The only part of an EV that can catch fire is the batteries.
What does a thermal runaway look like?
Well, luckily that wasn't a thermal runaway.
Not this. There's
Not
nothing
that.
left.
No, this is the early indications that something is going wrong with your battery. This is a plastic cover that goes over these batteries, and as you can see, there's one here, and it has a little white spot on it. I think this stuff starts to get hot and cook away at about 1,200 degrees. So that means
You
the bus.
mentioned voltage sag earlier.
Yeah.
How would that play into this? Because this wasn't the batteries getting hot, right?
No, that was the actual current collector.
Why?
Because what happens is exactly what you said. When you bring down voltage, you have to compensate with it by bringing up your amperage. Amperage is what produces heat, not voltage. So the more actual amps you throw through a piece of wire or a bus bar or a current collector, you're gonna get higher heat levels. So in this particular case, we were running 2 large drive units at Bonneville with a single Tesla P100D pack, and about 3/4 of the way down the salt flats, we were bringing the voltage down so low because we're demanding so much out of it that the current went so high that they're cooking current collector on this and getting it really hot. And as you can see here, right through the plastic. Luckily, it didn't go into thermal runaway, which is basically when the chemistry here starts reacting with itself, it produces its own fuel. It will ignite, and there's no amount of water you could throw on this thing to fix it. And also, electrical fires and water.
Don't mix.
Nope.
Class Charlie fire.
The Delta Charlie.
It's Class Charlie fire because it's electrical, but you treat it like a Class Delta fire, which is jettison. You just get rid of it, let it burn out,
Yep.
get away from it, get to safety. So, all right, now, since I said that safety, perfect segue. Let's move over here. And Danny boy, if you can get a picture of the top of this, what you'll see here is a bunch of individual little wires that go from cell to cell. All right? Mr. Wheeling Welshman, what's the purpose of these wires on top?
Fuses. The individual fuses. Every single cell in every single module has an individual fuse. So if you have one cell go bad for whatever reason, it's going to knock out the fuse, and your battery management system is going to pick that up immediately. That cell group has a lower capacity now than the rest of them. So that you'll know about.
Yeah, and also we do check some of the BMS systems that we work with, especially one from AEM. It measures resistance inside the batteries. So all of a sudden, your resistant value changes on one pack and one cell, you know something's gone wrong. Also, for the longevity of these cells, as time goes on, there's going to be a higher resistance inside the pack because they're degrading over time. What happens with these batteries, this particular chemistry, is they form something called dendrites between the anode and cathode. And basically, it's a little tiny short, and your capacity starts dropping and dropping and dropping. And when you're charging, it's also going to bring up your change your resistance levels as well. So if you're seeing your battery pack and you see a different resistance level on a certain module, you'll know that there's something wrong with it.
Okay, now we talked about there's 16 of these in a Tesla, and they're basically in the floor of the car. So you would have 16 of these modules configured end to end, side to side, and it makes up basically the floor of the car. Now, when
You know
you're
that was a
doing your
blank piece of
EV
paper,
build,
right?
it is pretty much a blank piece of paper, but it's representative of the power of a Tesla. Now, what you would do is you would break this pack apart, break out the individual modules, and you'd reconfigure them into a fashion that conforms to whatever you're building. If you're building a truck, you could put them all in the bed. Now, not the greatest for weight distribution, but you could do that if you're just trying to make a cruiser. In the dock, right, we actually spread them out throughout the car for weight distribution. And that's the beauty of a Tesla package. You can break it apart into individual modules. Now, Welshman, all right, tell me a little bit about what you did for the bike.
Well, with bike, it had been designed already around 4 modules that sat end to end, 1, 2, 3, 4, and it left us one space to put a bunch of batteries in. We had no reason to split them up, so what we did was we used one enormous box, one like 300-pound box full of batteries. These batteries, as a matter of fact.
Okay.
Same ones we used at Bonneville for the Little Giant.
Okay, so if you don't mind, why don't you walk us through the
Yeah, let's
battery
take a look
box,
at
what
that.
we got here?
So we figured we needed our voltage. Our voltage that we were running is 480. So you do the math and you work out you need 114 in series. And then for parallel, if each one's good for 200 amps, we needed at least 500 amps to run the controller. Then you start doing the math on the capacity and you realize that's not enough. So we went to 4 in parallel. So we're barely stressing these cells. We're pulling 120 amps out of them.
We've tested them up to 400.
Yeah, we tested 400, so we're pretty safe on the batteries. Everything else is unsafe, but the batteries, perfect.
And if I could add to that too, I mean, always make sure that you're not pushing these batteries beyond their limits, because if you do, you will get a fire, and that's not good for anybody. This is not gas stuff that like, oh yeah, just put more gas in it and we're fine. These things will blow up on you, so be very careful with that.
I'm cool. No, you're not.
Temperature monitoring is obviously another pretty important one. Like this one, the pack that got hot in the Bonneville car, these have thermistors on the cells, like hot glued right to the cells from the factory that you can tap right into.
But it did not have a thermistor on top. We
It did
didn't
not have a
we didn't
thermistor on
even
that.
know of this problem until after we disassembled the car when we came back.
So we knew the cells were fine,
Yeah.
because the thermistor on them was reading, I don't know what it would have been, 50C,
It
something
was
like that.
way
They
below-
were up there, but
yeah.
they weren't dangerously hot.
No.
But that's not going to protect you from a cable fire or a bus bar melting if you don't do your math right. So do your research. 2-aught cable is good in bursts up to 1200 amps and beyond for short bursts. So we're great on this one. On the positive side, we've got 2 sets of 2-aught. And on the negative side, 1. Yeah, we're totally good.
Okay, so now I have a couple of questions here. I noticed there's space between each battery. A couple of places I see spacers. Purpose of that is?
Yeah, so you need airflow between these batteries.
Why?
To cool them. Because even though at 120 amps they're not going to draw that much heat, we're going to be leaning on them for probably 60 to 90 seconds. So they'll start to get hot. If you've got no airflow at all, the ones in the middle are going to start to heat up. And as they get hotter, they're, like they said about thermal runaway. The reason the spaces look different here to here is because we ran out. These are from a C-Max. These are from a Honda Inside.
Okay, so what's going on here?
That
what's
whole
happening
mess
here? Yeah.
is in progress. That's the battery management system we talked about on the last video. Each one of these wires goes to one of these cell groups. So we said we did 4 in parallel. So if you imagine, for example, these 4 right here are paralleled. These 4 right here are parallel. These 4 right here are parallel. So each one of these wires goes to one parallel group as they go down.
Did you miss any?
1. If you get to the end of your cell tap wiring and you build your whole box and you have 1 wire left over, the problem. This will have to come back apart. We were in the rush for Bonneville and we figured a 1 in 114 chance of that one cell group that we weren't monitoring going bad was
acceptable
within
risk.
a safety margin, yeah. But this is
All
all
right.
a work in progress.
Okay, all right, well, there we go. All right, let's move on. All right, well now, all right, we talked about applications. We talked about safety. Anything else you guys want to add to that?
I just can't stress safety enough. We just had a client come in here this morning and we're talking about reconfiguring some of the batteries in his car. A lot of the ICE guys don't understand the potential of what sits behind these batteries. This little tiny battery, now I said I've tested up to 400 amps. I've pushed it to 800 amps coming out of this little tiny thing that fits in the hand, like palm of my hand. These are 2 very, very hot leads right now. Now there's only 3.7 volts behind this. If I drop this thing, which I have, onto something metal, it explodes. Like, not the battery itself, but whatever it connects to literally welds itself onto these 2 studs extremely, extremely quickly because you're pushing so much amperage. And that's where your heat comes from. So I can't stress enough safety. When you're working on this stuff, wear glasses. At the bare minimum, wear glasses, because by the time this thing touches something, you're not gonna be able to blink. I mean, it's speed of light, it's electricity. So that's a big thing. We've had a couple of small instances here at the office that we were very happy that we're all wearing gloves and glasses, because things do go pop. And I call it silent death around here because you won't hear it coming, you'll just see it when it's too late. So once again, safety, can't stress enough. These packs especially, so I was talking about 800 amps coming out of this little guy. This big one could push out over 2,500 amps. That's not what it's rated for, but that's what potential is behind there. So you drop a wrench between these two things at 24 volts, that wrench is gonna be gone, and hopefully your hand is nowhere near it.
And something else I keep seeing as a common theme with especially people's first time conversions is the gas guys, greasy hands, right? Angle grinders, all of this. You have to cover the batteries. You have to keep every little chip you can out of the batteries. If that means taking the whole pack apart, if you have to, like, remove the pack from the car, then do your grinding, your welding, your cutting, whatever it is, and put it back in. Because something as little as, you know, a tiny little strand of coil of wire out of a drill bit. If you get that across two of these, it'll blow the fuse and it won't catch fire, but it'll wreck that whole battery. You can't re-weld these fuses, not easily anyway.
So, ballpark, what would one of these modules, let's say you damage one of these fuses, the module is now no good, what would a ballpark figure be for replacing one of these? One of them.
On this, if you're stripping your own battery, it's at least $1,200, I would say.
What? Bro, what are you talking about, man?
Yeah, but anywhere between $800 to $1,200, $1,300, $1,400 for these bigger 100D packs. And also too, if you get anything down inside here, the tops of the batteries, the positive and negative are within a couple millimeters of each other. So if a chip falls down in there, it may not blow the fuse, excuse me, but it will start cooking that one cell. And that one cell will start to degrade on you. So once again, yeah, so this is all part of the safety thing. I have some really good fabricators that work with us, and even we make mistakes. I found TIG wire in one of my batteries once, and it just happens. So just be careful, take them apart, strip them. We just stripped a car for a customer the other day, and we found some chips inside the batteries, and we're glad we went through them. So, that's
So if you have plans on building your EV or doing some EV conversions or doing them for other people, I definitely recommend that legacy training.
Oh, yeah.
They go through the safety, they go through batteries, they talk about programming, they talk about, and this is something that's grossly underrated, they talk about what it takes to build an EV, right? The modules, the components, you know, and how to configure them. So a lot of this stuff is really important, and I definitely recommend the training if you wanted to do a conversion.
It's the stuff that you don't know you don't know. It's the stuff you wouldn't even have considered.
I wish they had something like this when I started, because there was like a huge learning gap. It's a learning curve. So when you walk in here, like, well, I know about electricity, I know all about motors, but there's all this other stuff that goes along with it that, gosh, if I would have known 5-10 years ago what I know now, I would have been able to accelerate a much faster rate of getting through a build. Because half of these builds, you're going, am I doing this right? And back then, there was nobody to turn to.
Right.
There was nobody you could call. There's no forums. It was just everything else.
Well, look on the bright side. Now, there's plenty of guys to call. There's 3 of them right here.
Don't call me.
Yeah. Now, okay. You know, I guess we're gonna wrap this up, and Lando, I'm gonna need you to calm down some.
Okay.
All right. Yeah. Okay. All right. So, thanks again for joining us on Revolt Garage. So be sure to like, subscribe, and definitely comment on the pages, and we'll get back to you with any questions you have.
Smash that notification button. We'll see you guys soon.